welcome to my YouTube channel. Myself, I am Lokita GS. I am from the Department of Artificial Intelligence. My USN is 1VE22CA030, SEM, 3rd SEM, Section Audi. Today's subject, which I am going to display, is Digital Design and Computer Organization. The subject code is BCS302. The topic in which I am going to cover of the subject DD and CO is combinational logical circuits versus sequential logical circuits. Introduction. Combination logic circuits and sequential logic circuits are two fundamental types of digital circuits. Combination logic circuits perform operations based solely on the present input values. Sequential logic circuits incorporate memory element to store and process information over time. Combinational logic circuits. Combinational logic circuits are also known as combinatory circuits or combinational circuits. The output of combination logic circuits depends only on the current input values. These circuits are built using logic gates such as AND, OR, and NOT gate to perform logical operations. Example of combination logical circuits. Adders and subtractors are common examples of combinational logical circuits. Multiplexer, demultiplexer, and encoder are also commonly used combinational logic circuits. The output of these circuits changes immediately when there is a change in the input values. This is an example of combinational logical circuits, and second one is a sequential logical circuits. Sequential logical circuits. Sequential logical circuits have memory element such as flip-flops to store information. The output of sequential logical circuit depends not only on the current input values but also on the previous input values and the state of the memory elements. These circuits are used to build complex systems like counters and registers and finite state machines. Example of sequential logical circuits. Flip-flops are the basic building blocks of sequential logic circuits. Shift registers, counters, and memory units like RAM are example of sequential logic circuits. The output of these circuits changes in response to the clock signals or external events. Sequential circuit example. Assume that the flip-flops are positive edge triggered and assume that they have all been reset to 0. Complete the following timing diagram of the signal A, Q2, Q1 and Q0. Initially, A has the value 1 or Q2 equals Q1 equals Q0 equals 0, 5. It is an example of sequential circuits where the circuits are connected in the sequential order and the output is exacted from there. Timing consideration. Combinational logical circuits are asynchronous in nature and do not require a clock signal. Sequential logic circuits are synchronous and rely on clock signals to synchronize their operations. Timing considerations are crucial in sequential logic circuits to ensure proper functioning and prevent timing hazards. Here is an example of block diagram of asynchronous sequential circuits. Firstly, sequential circuits is classified into two types: synchronous and asynchronous sequential circuits. The above given diagram is an example of asynchronous sequential circuits where the order isn't matching but the input and output is given. Here it consists of n input variables and m output variables. The number of input variables should always be equal to the number of output variables, and it also consists of k secondary variables, present state, k existential variables, next state. Block diagram of asynchronous sequential diagram. Number of digital circuits displayed in the diagram is 3. Design complexity. Combinational logic circuits are relatively easier to design and analyze. The sequential logic circuits are more complex due to the inclusion of memory elements and the necessity to handle timing issue. The design process of sequential logic circuits often involves state diagram, truth table, and logical equation. Application of combinational logical circuits. Combinational logical circuits are widely used in arithmetic operation, data processing, and logical design making. They are essential components in microprocessor, calculator, and digital signal processing system. These circuits are also used in control systems such as traffic lights and elevator controllers. Applications of sequential logical circuits. Sequential logical circuits are crucial in systems that require memory, sequencing, and synchronous. They are used in the computer memory, data storage devices, and communication system. Sequential logical circuits play a vital role in controlling complex processes and automating tasks. Conclusion. Combinational logical circuits are suitable for the application where the output depends only on the present input values. Sequential logical circuits are necessary for the application that require memory, sequencing, and synchronization. Understanding the difference and application of these two types of circuits is essential for designing and building digital system. Thank you. Please do like the video and subscribe it, as the number of likes gives the marks for the assignment. Thank you.